CTO of Netcom Wireless. Netcom Wireless is a leading developer of fixed wireless broadband, wireless M2M, industrial IoT and climate technologies, and was recently named the winner of the NBN Span Excellence Award for its contribution to the fibre to the curb rollout. Steve has been with Netcom since 2009. Please welcome him to the stage.
Thank you very much. So I'll try and be quick, get everyone to lunch as soon as we can. I'd like to start this session with a question, if I may. And I'm going to talk about broadband. And this is a question for an internal response. I don't want everyone shouting at me. Have a think about your broadband connection at home or at your work. And I want you to think about what it would take to make that connection better or perfect or ideal. That's it. Pretty simple. The idea here is to think about broadband connectivity and what it needs to be perfect. Now, most of the time when I ask this question, people say, well, my broadband connection is actually pretty good, though that tends to be in the minority of cases. Some people, the thoughtful people, will say, well, actually, my broadband connection is good in the morning, during the day, but at peak hour it's not so good. So I want my broadband connection to be just more reliable and consistent. That's kind of the thoughtful response, and I'll come back to that. But the most common response that I get when I ask that question, what do you want for your broadband connection, is they just go, oh, make it faster. I want more bandwidth. Now, this is not a new response. We're talking 30 years of built-in response for how we respond to your broadband connection to improve it. Let's just make it faster. And Netcom's used to this. We make devices, right? We make modems, we make products that live on the edge of the network, that connect you to the network. And all the time, our customers are saying to us, give us the next fast one. We want the next one, the next technology wave. And by that, the impression is the next fast one will fix all the problems and make it better. Guess what? It doesn't. It doesn't make it better. So what I'm going to talk to you today is about this concept of super fast broadband. I've chosen that term deliberately because super fast seems to be what everyone wants. They want super fast. What does that mean? Well, I'm going to challenge that today and talk a little bit about what actually you need from a broadband connection. Right, so super fast. What does it mean? I looked it up in the Oxford Dictionary and I got a very unhelpful response. Super fast equals extremely fast. Thank you very much. Extremely fast. It's useless. And their use case was a super fast broadband connection or super fast passenger trains. It got me nowhere, right? So how fast is super fast? What I'm going to say to you is it actually doesn't matter. The speed doesn't matter. What a lot of people will say, a lot of technology vendors like us will say, well, let's look at the use case, 4K TV. This is the usual response. This is from Netflix. And they've said, okay, well, for broadband, a couple of megs pretty good. Standard def, 3 megabits per second, 5 meg for HD, and 4K Ultra HD, 25 megabits per second, downlink. They kind of ignore the uplink bit, they ignore the latency bit, and they say, oh, you need 25. So if you've got 4 screens in the house and you're doing 4K TV, that's 100 megabits per second, right? Now, if you can find 4 screens worth of 4K TV and you can stream it, then well done. There isn't that much out there. But 100 meg is very short of what a lot of the industry is telling everyone you need, which today is everyone's saying, oh, you need a gig. A gig's where we want to be. The message there is it's actually not about the speed. It's not about that headline rate. Not anymore. It used to be with modems, 1200 baud, 2400 baud. When you bought the next one up, it was twice the speed. That's the PHY rate. That's the physical rate from modem to the infrastructure. That's not where the bottleneck is anymore. The right response now is super fast broadband is giving the customer what they signed up for. Not at 3 in the morning, but all the time. Now, that's actually a hard thing to do. I'm not trying to be radical here, but the industry doesn't do that today. The industry promotes up to speeds all the time. So I've put this slide up before. I've talked about it before. I'm only going to touch on it briefly today. What I'm talking about here is broadband as a service, like water, gas, sewage, power. They should just work. At 7 o'clock at night, if 2 people flush the toilet at once, it still works. You don't get one backing up just because it's busy, right? Broadband should just work. Now, it's not just about the physical rate, the connection from modem through to infrastructure. It's about the end-to-end experience, how you go from internet through the network core, through the distribution, to the modem, through the house, to device. End-to-end picture, how you put assurance around that. I'm not making this up. Big operators around the world, I've got an example here of AT&T. They happen to be a customer of Netcom. There's a customer we work with very closely. They have a new corporate strategy that was announced in their recent annual report. Nowhere does it say we're going to give a gigabit speeds. Number one, deliver an effortless customer experience. Number two, lead in connectivity and integrated solutions. And then it moves on. I won't go through the whole lot. The point here is that they've worked out at AT&T that to deliver a service to their customer, it's about the customer experience, what they get. Not about the speed, not about the technical details, just make it effortless, make it work all the time. And to do that, it's not about providing the latest technology, it's about creating an integrated solution environment. Because this house and this house and this house, the other side of the states, they work differently, they have different geographies, and one solution does not fit all. That's their corporate strategy. We happen to be participating in that strategy for their rural areas, which is great, but they're doing it. Not seeing this language from Australian telcos at the moment. How do we do it? In Australia, oh, we're very special in Australia. We've got NBN that makes things really complicated. No, I disagree completely. The NBN is just another piece in the pie. Here we have the typical network environment. I've simplified this down. I don't want anyone to kind of say I got my network architecture wrong. This is a simplified version of what you see. On the right-hand side, we have the internets, right, doing its thing. We have a connection through to the RSP. They have their core transport systems. They have their aggregation, and they have an edge router. Very important term, edge router. What does edge router imply? That's the edge of my network. That's where I stop. Come back to that. Then they have a point of interconnect where you have a Ethernet wholesale service from NBN, which takes you to the premise. And then there is a gateway in the home. And for fibre to the node, it's a VDSL gateway. For most other things, it's an Ethernet interface. And then there's a gateway in the home that provides Wi-Fi and Ethernet services into the home. That's how it is. And if you look at it, that area in the dark blue, the RSP controlled service, that's the thing that they spend a lot of money on, buy some very advanced equipment. This is the RSPs. And manage and control very nicely. Quality of service, the works. Problem is, it doesn't do the job. There's all these links in the chain that are not my problem. So as a customer, when you sign up for X service, you don't necessarily get it because your body that you're subscribed to, the RSP, can't control all the bits in the puzzle. So you get this situation like we have today in Australia where you've got people doing this at each other all the time. They're saying, my service is no good, it's NBN's fault, or vice versa. It's the RSP's fault, it's the gateway, it's Wi-Fi channels. Actually, you know what? Not many people know what the problem is because everyone's different with different faults. How do you fix it? I'm not going to stand here and tell you it's all a big problem. It can be fixed, and that is to control the service all the way to the end entity. I've extended the blue box and magic happens. Right? The RSP modem is a point of presence in the home, and you can put intelligence in it. Today, not being done. Can be done. It actually requires more intelligence in the modem. It actually requires very detailed diagnostics and remote management and service delivery and quality of service. Can be done. Most of it's actually software smarts. But you need a modem that has the ability to run those smarts. And unfortunately, what we have in the industry is the drive to the bottom line, which is to make the modem and all the bits in the puzzle as cheap as they possibly can be. But that then takes out the ability to differentiate your service and offer quality broadband to your end user. So what's missing in broadband delivery, this is my end of my lecturing, is the ability to deliver super fast broadband as a service as promised. That's missing. The unknowns in the network, they've become the norm. They've become the thing that everyone just accepts. For 30 years, people accept that they've signed up to ADSL2, which could do 25 meg and does 3. People are kind of used to it. but people are moving on. It's becoming this service that you expect to work, and the industry needs to catch up. The CPE, the device at the end of the chain, has become a commodity. It's not valued. Make that part of your network offering, and you can do some smart things. That implies then that the device is not going to be an off-the-shelf device anymore. It's going to be uniquely engineered to match what you, the network, want to do. So there's some engineering to do. That's good. We like engineering. Therefore, one size does not fit all. So that's the end of my talking about what the problem is. I now wanted to touch a little bit upon what technologies we see coming at Netcom. We're a devices company, like I said. We make access equipment. So I wanted to touch on the few key areas that we're focusing on and give you some insights into where we think it's all going. There's a handful of connection mediums or physical mediums that we think are relevant. And in fact, in Australia, we've got all of them in play today. It's quite unique, actually. When I go and talk at other events around the world, they tend to be one or two of these. But in Australia, you've got all of them. Wireless, fibre, copper, HFC, they're all relevant. Now, at Netcom, we deal a lot in the wireless space, and the fibre and the copper, we have a fibre to the curb product there. HFC, other vendors are looking after. Fibre to the curb has become a bit of a hot topic in Australia. We are working on the VDSL version of that, which is the right technology for today. It's a fibre in, it's a VDSL out, providing services through to homes. The next wave that's coming really next year is G.fast in what's called 212 meg profile. That's kind of a little point that some people miss. Everyone thinks G.fast's a thing. There was an earlier version of G.fast called 106 meg. It was kind of a pre-standard for G.fast. And a lot of activity going on in the last 18 months, but really it's not the end game. The 212 meg profile is the end game. It can do a gigabit services, and that's the one that's really ratifying, and silicon's being released now, and that's the one that we've been working on. Just earlier this year, Netcom, we did an announcement for a reverse-powered DPU at British Telecom, or Openreach, and that achieved 1.6 gigabits per second aggregate. That's uplink and downlink together. So that was a bit of a world first for this sort of reverse-powered, remotely powered distribution point unit. So that's something that we're focusing a lot of development dollars on at the moment. I believe in Australia this will become relevant, but not right now, simply because the silicon's still very immature. So we've got another 12 to 18 months, I think, before we'll see that technology become ready for showtime. Fixed wireless is the other area that we're playing a lot in. Right now we have the NBN fixed wireless product that Netcom makes for Ericsson and gets installed for NBN, really for rural areas. And today that's all about 4G. And we're seeing that move very quickly up to 5G. And I wanted to spend a little bit of time today just talking about 5G and how real that is and some of the hairs on that. Because there's been a lot of press about 5G, and I sort of sit back and go, well, there's a lot of stuff that's not real about what people are saying here. So I'm going to spend just a few minutes talking about 5G. But first of all, where are we today with 4G? What can you get today? Well, just earlier this year, NBN did a press release for their new LTE Advanced, which is an advanced 4G solution. And they did a demo of 100 megabits per second down and 40 megabits per second up. And that's a guaranteed service delivery. So you'll get that over the air as your physical rate. That's where really technology is today. And in 4G, what you're talking about is 20 megahertz channels, physical airspace. And they aggregate those channels together, and this device actually can aggregate up to 4 channels together, and it sort of runs in parallel. We're kind of stretching the limit of 4G Advanced with 4 channels. There's a thing called 4G Pro, or LTE Pro, that can do up to 6 channels, but you're really just gluing together these 20 megahertz channels into a bigger thing. 5G does not do that. 5G widens up those channels from 20 megahertz to a much wider bandwidth. And therefore you've got wider bandwidth to play with. You can change your modulation scheme. You can do much more exciting things with the 5G. But that's more around the broadband piece. 5G, on the other hand, can also be used for a few different use cases. And the 3 they talk about at the moment is broadband, mission critical, and massive machine type. They're the 3 areas that 3GPP is working on today. Let's dive into them quickly. In 5G broadband, that's the one that Netcom, we're spending a fair bit of time, because fixed wireless as a use case for 5G is absolutely one that we're pursuing, and a lot of industry talking about this as the kind of first cab off the rank, if you like, of what do we do with this 5G technology. There's a few problems with this, because to do broadband 5G, you need a bunch of spectrum. So you can't do it in the spectrum that everyone's using today. Telstra, Optus, Vodafone, they've got spectrum, but it's all 5 meg or 10 meg or 20 megahertz channels. You can't glue that together or have a big enough channel to do what we're talking about here for 5G broadband. So everyone's talking about millimetre wave, 20 gigahertz plus. And it's different depending where you are in the world. Now, broadly speaking, Europe, they moved on the sub-6 first, so there's no big channels. It's all about optimization of the base station, massive MIMO. But now they're starting to work on allocating some bandwidth, some spectrum, for millimetre wave. In the USA, however, it was all about millimetre wave, 28 gig, 36 gig, they're going for that. And then they've got some sub-6, but it's a shared spectrum, a thing called CBRS. Lastly, in Australia, well, it depends on who you talk to. ACMA started moving on this just recently. Different operators are lobbying for different things. So we'll see what pans out. It's not the same worldwide is the point. But broadband use case for 5G is absolutely going to happen. At millimetre wave frequencies, the propagation is terrible, hundreds of metres. Won't go through walls, won't go through glass. So the use case, the fixed wireless use case that we have, which is an outdoor device on the side of the home, point-to-point links, is actually something that is looking very promising for this use, this application. Mission critical, it's another thing altogether, 5G. This is not about broadband, this is not about wide channels so much, this is about low latency, reliable, peer-to-peer communication, so vehicle-to-vehicle communications and the like. Why am I bringing this up? Well, the device that does a mission-critical application is going to be very, very different from a device that does a broadband application. And the way the network is configured is going to be very, very different as well. You think about a network operator who's building their network for 5G, which application are they going to build for? Low latency or throughput? Mission critical or surfing the web? They actually do affect the way you can configure the core and set up your use case. So it's going to be very interesting to see which operators go for which use case first. Lastly, the machine-to-machine. A lot of hype in the world about machine-to-machine, IoT. 5G will be doing this as well. It's all about low band spectrum mostly, so that they get the maximum coverage. And also, it's all about how can you do it as cheap as possible. Now, this is the slide I really wanted to get to. Here we have the evolution of 2G, 3G, 4G, 5G. And an overlay on that to show you how it took place. Originally, 2G, we're talking GSM here, started as a voice network. Then some bright spark said, hey, we can put data over this, and they did an overlay called GPRS, which became a packet network that overlaid on top of GSM. And then in 3G, from the word go, they had a voice network and a packet data network, and it was the two things, HSPA, HSPA+. In 4G, they kind of got it right. They got rid of all these different networks, and they just consolidated it down to one data network, one data core, and voice fell down into an over-the-top network, voice over LTE. So now we have a really elegant one data layer 4G, and 4G's been massively successful for that reason. But it doesn't do everything you need. So we're already seeing this nice, elegant one data to rule them all 4G networks start to split, start to fragment. And for those who follow it, there's a thing called narrowband IoT. That's splitting out, and that's becoming its own sort of subset of 4G. And 5G is just extending the theme. We're now splitting out massive machine type, mission critical, super fast broadband, splitting into different use cases. I'm not saying here that you need different networks for each one, but I'm saying that the way you tailor it, the way you configure it, and the devices that run on the network are going to be very, very different for each one. Is anyone talking about this yet? No. Are there devices for each use case yet? No. So 5G's got a wee while to go. From a standardization perspective, the non-standalone is done. That means there's a 4G anchor band with a 5G traffic band. That's done. You're going to see some stuff in 2019 for that. Silicon's really ready for showtime in 2019, 2020 for when it really happens. The full standalone 5G isn't going to be till 2020, 2021. And then these use cases have to evolve. It's a great technology. It will find its niche, but it's not going to come in and wipe out all the other technologies, the copper, the HFC, the fibre. They're not going to be replaced by 5G. Anyone who says, oh, 5G's coming, don't do anything until 5G comes, they're dreaming. It's not the way it's going to play out. So, what's my message been today? A few fronts. One is consumers, end users are moving on from the we need the new speed thing. This hamster wheel of just give me the new speed, give me the new speed, because they've worked out that they get fast speeds at night and during the day and not at night. It's not a physical interface connection anymore, it's network structure, it's end-to-end quality of service. And they want that fixed. They're asking their politicians to get it fixed. The ACMA here in Australia is getting involved. They're putting in broadband monitoring. The impetus is there. That's what's changing. And to do that, it requires a radical rethink of how networks are built, and how they're run, and how that service is delivered through to the end users. Now, that doesn't mean we shy away from these technology upgrades, G-Fast, fixed wireless, 4G Pro, 5G. They're still going to come. They're still very important tools in the toolbox, but none of them are going to be the app killer that comes in and wipes the existing legacy networks off the shelf. So the way to do it is to build in readiness for these demands that are coming tomorrow, next year and the year after, and build an infrastructure that can be scaled up and can be run as an end service and not just as the next technology wave that's coming tomorrow just for the marketing headline. Okay, thank you very much.